Well, welcome. We're going to let folks go ahead and get seated. Welcome to our 10th annual Halloween in the Science Lab celebration.
Thank you.
The 10th one. The 10th annual. It's the 10th time we've done this. Yeah. My name is Dr. Kunselman. You can call me Dr. K. And I teach chemistry here at Spring Arbor University. And myself and a lot of the people that I work with, are here to do some experiments for you. We have, I thought that was Dr. Baratovich. He looks kind of funny tonight. I've never seen him like that before. You can call him Dr. B. We have Ashley. Yay, Ashley. We have Jed. Dr. Baldwin. And we have a very special guest tonight. Now, the first time we've done this, we have a special guest from Jackson College, Dr. Ott.
You can call me Jude. That works.
We have a lot of experiments planned for you in here. We're going to have about a half an hour chemistry demonstration show. And then after our show, you will be invited to go across in that direction to the Whiteman Gibbs Science Center. And in the Whiteman Gibbs Science Center, we have a lot of Spring Arbor University students who have hands-on activities and science demonstrations prepared for you. So you get to trick or treat throughout the science building, and you get to do some science experiments, and maybe even get a little bit of candy. So welcome. And I wanted to start tonight's experiment with a brand new experiment that I invented, actually just this week.
Oh, that's amazing.
It happened during class, and I liked it so much, I thought, maybe we'll just kick off the show with this. So what I'm going to do, I like to call it the Wizard's Milkshake. The Wizard's Milkshake. So I have a little bit of water here, and I'm going to put in some calcium metal. And calcium metal reacts with water to form a solid, and that solid's white, but it also makes some bubbles.
Oh,
and those bubbles are hydrogen gas. And hydrogen gas, if you let it on fire, it'll react with oxygen in the air.
Oh, the water's on fire. Wow, that's amazing. And it's beautiful red because of the spectrum, calcium ion.
That's right, it is. Yeah. That's right. That red color is coming from the calcium that's in the calcium metal that we dumped in. And look, when we're done, it's a little bit warm. It looks like a milkshake, doesn't it? Looks like a vanilla milkshake. I got a few more bubbles here. Let's see if those are made of hydrogen gas. Oh, yes, they sure are.
They were.
So there's your Wizard's Milkshake to kick us off for the night. Thank you. Tonight's experiments are going to be all about carbon dioxide. It's a gas. We're going to learn a lot about carbon dioxide tonight. And sometimes we chemists, we talk about substances in a shorthand way. Maybe you've heard somebody call water H2O. You ever heard somebody do that before? Yeah, I've heard that. That's right. We chemists sometimes when we talk about water, we call it good old H2O. Well, sometimes when we talk about carbon dioxide, we just call it CO2. CO2, and what that means is the gas carbon dioxide, the molecules that make it up, they have one atom of carbon and two atoms of oxygen, and so we call it CO2. And over here, Dr. Baldwin is going to do an experiment where he's going to try to produce some CO2.
I'm going to, wow, all the way down.
I'll let you take it away, Dr. Baldwin.
Okay, so I'm going to make CO2, but you're not going to be able to see the CO2. I'm sorry. That's going to happen after I light it on fire. Let's see what happens. Boy, kind of dangerous looking. Wow. Oh my Lanta. Look at that. I'm going to step back. Wow. burning, like you'd burn a chunk of wood. But way up at the top, what you can't see is all the carbon dioxide it's making, because the theme of our show is what molecule? Carbon dioxide, or CO2. Yeah! Wow, there was a lot of fuel in that, wasn't there? Just keeps burning and burning and burning. How long do we want this to burn, Dr.
It's probably good enough. We don't want the towels in.
Yeah, we don't.
Let's have a hand for Dr. Baldwin. Now what we're showing you there is that what Dr. Baldwin did, the towel was soaked with the fuel. And when we burn fuels for all sorts of different reasons. They help us do all kinds of things, like heat our homes. And when we heat our homes, we burn fuels, and that usually gives, well, it always gives off carbon dioxide. And so, some of the things we'll be talking about more this evening will be about carbon dioxide. We're going to let Dr. Ott do a particular experiment here with burning fuel. Take it away, Dr. Ott.
So, there are 3 things that you need for a combustion reaction. Those are fuel, so something that burns. We need some oxygen, and we also need some sort of ignition source. Now, people ask me, why did I go into chemistry? And it's not for any sort of like big fancy, I wanted to solve the world's problems or anything like that. No, it's like making colors. One of the things,
that is great.
and one of the things that I learned a long time ago is that flames are really sort of like the same color. So that flame on your stove, if you have a gas stove, it's kind of a blue color because it's methane. Or you've seen yellow flames, you just saw a yellow flame.
Yeah.
Or sometimes you see a red flame. I don't like any of those colors. I really like green. So, what I'm going to do inside this barrel is I have some methanol, but I've also added another chemical called boric acid. Can you all say that with me? Boric acid. Not boring acid. It's not boring at all. I do want to ask the house manager, can you turn down the lights for me? Because this demo will be really cool. Now, one of the things that's really important is this demo is going to actually make a really cool noise. And there's going to be an initial sound, but then there's going to be a next sound that's much, much quieter. And so we really want to hear that. So I know this is going to sound silly. And if I just told you to not make a sound after the first one, like if I told you to just be quiet, you won't be able to do it. Just trust me on this. I've been doing this a long time. So this is what we're all going to do. You're going to take your left hand, hold it up like this, and then put it over your mouth. And then take your right hand, and put it over your left hand. Okay. Another earthquake. And now if I can have the house lights brought all the way down. And the stage lights. And the stage lights. And the stage lights. And the stage lights. Ready? Or not. Thank you. So now, what this barrel was filled with, was just air, right? So air, the air that you breathe has nitrogen and oxygen, and so I put the methanol in it. That was our fuel, and the oxygen in there reacted with it, and now all the methanol and the oxygen is gone, and now the only chemical that's in there is more of our, where's your poster? Carbon dioxide. Everybody together, carbon dioxide. Awesome. Dr. K, what's next?
Let's have one more answer. Now, because we have Dr. Ott here tonight, I figured we'd do a special demonstration in his honor. What we have here are some flasks. And we see in one flask we have a blue liquid, and another flask we have a yellow liquid. This happens to be the colors of Spring Arbor University. Yay! And Dr. Baldwin and Ashley, they're going to breathe into these fluids. They're going to blow bubbles into these fluids. And when they do so, go ahead. When they do so,
So
we'll
I'm
be...
going to stand.
So, what I want you to know before they start filming,
Remember, when we breathe in oxygen, and we breathe out carbon dioxide. With every breath, you are producing carbon dioxide.
Even them?
Even them.
Wow.
Even the smallest of them.
Even them.
So you'll see that his is yellow, and hers is blue, right? So if you look down below, you have this color matches, right? These solutions are slightly basic, right? You've probably heard of the word acid, right? Heard of acid? You ever heard that word?
I've heard of acid.
You've heard of acids, right? We have acids, and then their sister molecules, their sister compounds are called bases, right? And so what's in these bottles are special chemicals that are going to change color when they start blowing into them. So I want you to pay very close attention to their color. Thank you very much. Go ahead and start blowing.
Okay, blowing.
I hope this works.
Blow in. Don't suck yet. This is not a straw. It's not a drink. It's not a drink. We got to see if there's a color change. We're going to hope there's a color change.
We're gonna hope there's a color change. This one.
Not saying you're full of hot air, but
We might need to help out. Sometimes we will. Sometimes we do need to help out. Oh, 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 oh.
we can make a competition. Absolutely.
We're getting there. Maybe we need some help from our friend.
Oh, yeah, our friend.
I think our friend dry ice might help us. Did you see some color change in Ashley's? We've got a little color change in Ashley's. What we're going to do here, we're going to add,
My aim isn't all that good.
we're going to add some solid carbon dioxide. See if we can't get this. Let's see if we can't get it to go. Come on. Come on. There we go. Finally.
You loosened it up.
See what we planned here, we planned, of course, to teach you a little bit about carbon dioxide. And when carbon dioxide bubbles into solutions, it makes them acidic. And when carbon dioxide gets into water, it makes the water more acidic. And there's another thing that we did here. You see these colors?
They were blue and yellow, which is Spring Arbor colors, and now they're kind of gold and maroon, which is Jackson College.
Oh yeah.
So in those flasks were special chemicals that we call indicators. Now indicators change color depending on how acidic or basic the particular solution is. And there are dozens and dozens and dozens of different kinds of chemicals that act as indicators. They're one color when it's acidic, and they're another color when it's basic. And so one of the things that we do as chemists, if we want to make lots of different colors, we want to measure different acidities, is we mix many of these indicators together and get something that's called a universal indicator. So what's in this solution, as you can see, it's sort of like purplish. If I had a background, where's our CO2 sign? Can I draw that CO2 sign? I need you to bring it over, just so we can have a little bit more color background. All right. And so again, what we're going to do is we're going to drop in carbon dioxide. There goes the CO2. There's our making of CO2. And what I want you to do is pay very close attention to what's happening to the color inside of the tube.
Yell out the color when you see it change. What's happening now?
Oh, look at that. And this is awesome because I'm making a mess, which is the other reason why I'm a chemist. Yeah, because I can get away with making a mess. Hey, that was a pretty cool color change. I'd really like to see that again. Can we make it go backwards?
Okay.
Well, do you remember what we said the opposite of an acid was? A base. So what I'm going to do is I'm going to add some sodium hydroxide.
That's basic.
Oh! Oh, I see a goon. And I add enough to go all the way down before it.
So it goes green, then blue, then orange.
All right.
Now that carbon dioxide.
I don't know about you, but I can do this all day long.
Yeah, we're done.
All day. I'm just going to keep doing this as fun.
All right, let's have a hand for Dr. And one thing we use carbon dioxide for is a fire extinguisher. And Dr. Bradovich is going to demonstrate that for us now. Take it away, Dr. Bradovich.
Okay. Did you know you can make water burn? Let's see. Make water
That is an
burn.
environmental disaster. I don't think he's not.
I think the water needs a little help.
Hold on there.
Or does it need some help?
Oh, this is okay.
Okay.
I'll hold it back there. Okay.
What can you do? We're going to put some stuff called ether.
Ether.
Ether is a very strong smell, but it'll help the water burn.
Water burn?
You can't burn any
You
water.
can't burn water.
Whoa!
Yep, it burns.
I thought
And now we can use,
Oh, it's like a fire extinguisher.
yeah,
Put it right out.
That's fantastic.
that's dry ice. What's that dry ice producing?
Carbon
dioxide.
Okay, just for the rest of the show, if anybody asks you a question, the answer is always carbon dioxide.
Okay.
All night long. I'm just gonna let you know that.
So we have fire extinguishers that are carbon dioxide fire extinguishers. They put the fire right out, don't they? Because fire needs air to burn, carbon dioxide is not oxygen.
Nope.
Because it's not oxygen, it chokes the fire, puts it right out.
Have a hand for Dr. Bradovich.
Here you go. We're good there.
Okay, this next experiment that we're going to do is also going to deal with carbon dioxide. And this is going to deal with carbon dioxide that people exhale. We've already talked about how when you exhale, part of what you exhale is carbon dioxide. About 4% of your breath, about 4% of what you exhale is carbon dioxide. And I'm going to do a little experiment here with some water that has some calcium ions in it.
Calcium. Started with that.
Calcium ions.
The milkshake.
Pour a little more in there. And now I'm going to blow some carbon dioxide from my breath into this flask. And let's see what happens.
It's going to be a stinky flask, but I tell you. Is anything happening? Absolutely nothing. You don't see anything different.
Oh, wait.
I see something.
Did something happen? Yeah, what color does that look like? It looks white.
White.
Would you believe that what I made in here is the same stuff as what seashells are made of?
You made
I made the same chemical as seashells.
Oh, the same
So when I breathe into this water, the calcium ions in the water reacted with the water and the carbon dioxide from my breath, and it made calcium carbonate. Seashell stuff.
I'd be more impressed if you actually made some seashells. A little harder next time.
Listen, buddy, you're a catch, all right? We don't have to fight you next year. Let me see. Oh, I want to show you something else here, though. Something else here. You see, the way seashells are made is, of course, there's calcium ions in the ocean, and then there's carbon dioxide in the atmosphere. And some of that carbon dioxide in the atmosphere or the air, it goes down into the ocean, and it reacts and it makes seashell stuff. But there's another effect that can happen. And that effect I'm going to demonstrate to you here. You see, we have to remember that when carbon dioxide goes into water, the water gets more acidic. And so it can be the case where you can have water that gets too acidic for seashells. Seashells dissolve when the water gets too acidic. So what we're going to do here, I can't make this water acidic enough with my breath. But if we put in some pure carbon dioxide, I'm going to ask somebody who's got a glove hand to pop in here. We're really putting in a lot of carbon dioxide. There it is. There's the seashell stuff.
I see the
See it? So we made the seashell stuff. I'm going to go ahead and let that carbon dioxide bubble through a little longer. We may need a few more pieces to really get this acidic. There we go. Thank you. Who's watching that? It is beautiful, isn't it? It's like a big smoky white glass. The whole thing looks smoky and white. Sure does. Now remember, as the carbon dioxide bubbles through the mixture, it's getting more and more and more acidic. More acid. More acid.
You really dropped some acid.
The jokes don't get in the middle, folks. We're not comedians.
Basically, we need to have it.
I think it is.
We thought dad jokes were bad, right?
Chemistry jokes are the worst.
Does it look like, can you start to see the pieces on the bottom? Yeah, it wasn't that thick before. I can start to see the pieces on the bottom. Uh-oh, I think it's starting to get too acid for the seashell stuff. Look at that.
Oh, it's going
Close. We're getting close. The water now is too acidic for the seashell stuff to survive. And we see that the seashell stuff has dissolved. And now I can see right through the solution, and I can see through it. So what this tells us is that there's a balance that's required. The ocean can't have too much carbon dioxide, because if it's got too much carbon dioxide, then you can't have seashells. It's got to have a little bit of carbon dioxide so that you can have seashells. And that's a balance that we need to keep. And what we're noticing, as you probably know, that when we burn fuels, we release a lot of carbon dioxide into the atmosphere.
Remember my burning?
And that increased carbon dioxide in the atmosphere, biologists are telling us, it can get to the point where it's going to cause problems for living things in the ocean that depend on seashell stuff, calcium carbonate.
Wow.
Okay. Dr. Ott is now going to talk to us a little bit about ways that scientists are trying to deal with this problem.
So, ever since every animal on the planet breathes in air, breathes in oxygen, drinks water, and exhales carbon dioxide. Every animal that you've ever seen that's ever roamed the earth. Right, so we're producing all this carbon dioxide, but there's also something in the world that's eating all that carbon dioxide. We call them trees. Right, so everything that's outside, all the trees and all the plants in the world are taking that carbon dioxide and they turn it into oxygen. They go this direction, turning carbon dioxide into oxygen. We go oxygen to carbon dioxide. And that's the way it's been for millions of years. So when we started burning fuel about 150 years ago, we started putting way more carbon dioxide into the atmosphere, right? In addition to all the carbon dioxide that we're breathing and such, we have produced a lot more carbon dioxide. So scientists are trying really hard to come up with ways of how to clean the air and how to clean that carbon dioxide. Now there are a couple of methods that have been used for a while. If you think about the space station or the astronauts that went to the moon, they are breathing carbon dioxide and then they're in that little tiny confined space. And so if you're in a very confined space, the carbon dioxide levels get really toxic really fast. And so one of the things they will do is they put in scrubbers. Right? And what a scrubber is basically sodium hydroxide, which is a base. So in this can, I have some carbon dioxide, right? So it's just pure carbon dioxide. And what I'm going to do is I'm going to add some sodium hydroxide, which is going to react with the carbon dioxide, and it's going to go into the solution, assuming everything works.
Mason, no.
Listen very carefully.
Do you hear something? What's happening? Is it getting really big? Or the opposite?
Holy cow.
He's really strong. He doesn't look like he's working very hard.
I can crush it with my mind. And a lot of shaking.
That's really
So all the carbon dioxide is going away, it's being dissolved into that sodium hydroxide, and so now there's no gas, and so what's happening is since there's no gas on the inside of the can, it's pushing back on the can implodes, and so it's just the atmospheric pressure that's going in and breaking it. And I need a volunteer or someone, I just need a witness. Come on up here. I just want you to touch that with your bare hand and tell me what you hear. Is it warm? Is it really hot? Are you cold? You're not? Oh, okay. I was going to offer this if you just right. You might want the warmer. Let's see if we can get the other one to go a little bit faster. Okay, one more. See if I can make it go faster.
Okay, watch what happens. Well, he's working hard.
I'm expending a lot of carbon dioxide to make this carbon dioxide go away. Just saying. Okay, so you're about to
Let's have a hand. That's so cool. I gotta tell you, one of my favorite things to do with carbon dioxide is to put it into water and make a cloud. And you know what? Actually, Dr. Ott and I, we published an article together on how this happened.
We did.
You should have. That would have been kind of cool. But anyway, we'll go ahead and do this for you. When you put dry ice in water, you can see the dry ice immediately going to a gas, and you can see a beautiful cloud that's formed. Cloud's made of little tiny liquid water droplets, and the cloud actually comes from the water that we're pouring into the graduated cylinder. That's where it comes from. We'll go ahead and try this.
I don't want to put more of that.
Yeah, I think that's probably good. Let's see what kind of clouds we can get here. We'll put a little bit of dry ice in there and hope for the best.
A little bit? Did you say a little bit?
No, I said a lot.
Okay.
We're going to do a giant little bit. Look at the cloud.
Beautiful. Wow. And I thought it might be fun to go ahead and do it across here at different levels of the stage. I just love looking at clouds. I love the beauty of it. Just gorgeous. Just a beautiful, beautiful experiment. Yeah, okay. Good. Sometimes it's just fun to just do experiments, just watch it. Wow.
If we're really good, we could fill the whole room, but then we couldn't breathe, so that'd be bad.
Yeah, that'd be the end of the demonstration. Wow.
Isn't that beautiful? Absolutely beautiful. Well, at this time, let's have a hand for all the scientists up here. And at this time, I'd like to invite you. Oh, I'm sorry, we have a few announcements here first from Kathy Schaefer.
Thank you all for coming, first of all.
Okay, go for it.
This is a free event for you guys, but it does cost us quite a bit of money to run the event. And so if you'd be willing to make a donation, we do have a pumpkin that's hungry, and you can find it over in White McGibbs on the main floor. If you can't, we appreciate you coming, and don't worry about it, but if you're able to make a donation, we would appreciate it.
At At this time, I'd like to invite folks to head over to the White and Gibbs Science Center and enjoy trick-or-treating with science. Thanks for coming out tonight, folks.